Alrighty then, corn children, children of the corn. It is another fine day for mathematics, and we are going to be looking at transformations of a non-parent function. Where? All right, take a look here. And I believe I have included in your resources this particular graph. So double check that, pause the video if you need to, and you may want to print that resource. All right, so here's what I have here. This is the function f of x. It is not a regular parent function. It looks to be array, a segment, an array. It is the function f of x. And I've labeled a few of these points here so that you can see them pretty clearly. Point A, B, C, and D, and here are the coordinates. So this is what I'm giving you. This is a function, it passes the vertical line test. But our job is actually to figure out what some new functions would look like. Functions that are transformations of this function. All right, so let's take a look here. Our first one that we're going to look at, let me slide that a little bit over, is going to be g of x. And here's how I'm going to define g of x. It is going to be the f function, but inside of here, not just plain x. No. Now I'm putting in x minus 2. All right, do you see what I've done here? Where there used to be an x, there's now an x minus 2. In with the x, we see a negative 2. And if you recall, if you are in with the x, this will affect the x coordinates, but it will do it backwards. What? If this is minus 2, this is actually going to move our point to the right. How can we do that? Well, one way is just to move each and every dot 2 points to the right. And to be perfectly honest, that is what I would do. But if we want to slow it down now, here's what we could do. When you are in with the x, you're going to do the opposite of what it says to do. This says the x coordinate minus 2. You would actually add 2, not to everything, just the x coordinates. So if you consider with me, I won't do all of these, but if you will consider with me point A, the x coordinate is negative 6. If you add 2, it would become a negative 4. The y coordinate is not affected. So this point at negative 6, 0 would become negative 4, 0. And you could treat that like a prime, or the first change in a. So here we go, move it right 2. Do you see what I'm saying? Doing this math is fine, and we are in the right location, but if you can just figure out that it moves right 2, you can simply take dots and move them right 2. Now I have enough points here, 2 points on every single line or line segment or ray, and that should be sufficient. And if you want to get all kinds of fancy, you can use your ruler, ray, segment, ray. All right? And that would be the G graph. That's not so bad. Not at all. And if I'd done it neater, it would even look the same. Okay, let's try another one though. This is going to be the h of x graph. And here's how I'm going to define it. F of x plus 1 plus 3. Yeah, that's got 2 things going on. All right, so once again, we're starting with the f graph. We're going to be looking at the shape of the f graph, the nature of the f graph. And I have here a plus 1 in with the x, and I have a plus 3 not in the parentheses, so therefore not in with the x. That's the question you have to ask yourself. Are you in with the x, or are you not in with the x? All right, let's take a look at this plus 1. This plus 1 in with the x will change x things. X coordinates are righty-lefty things. So this will change the X coordinates, and again, it is backwards. When you're in with the X, you do the opposite of what it says. If it says +1, we are actually going to go left 1, and if you need to do the math for that, if it says to add 1, you actually subtract 1 from everything. No, X coordinates, because you're in with the X. However, do you see this +3? Not in the X value, in with the X value. It is not going to change the X coordinates, it will change the Y coordinates, and Y coordinates are uppy downy things. Unlike the X, we do not do anything backwards, you do what it says. So this right here, I know, is going to move the graph up 3. And if you wanted to physically do the math, you would do what it says. You would add, because it says add, do what it says, add 3, but not with the X coordinates. You would add 3, because it's not in with the X, you would add 3 to the Y coordinates. So if you wanted to physically do the math to the A point, now over here is the A point, it's -6, 0. You could take -6, 0, and we could do the following. Subtract 1 from the X coordinate. -6 minus 1 becomes -7. And then to the Y coordinate, you could add 3. And this would become the transformed version of the A point. So if this is A, you could call this a, I don't know, with a subscript of H if you wanted for the H graph, all right? It's the point -7, 3. Let's take a look at it. Where is -7, 3? Well, if this is -6, -7 is here, and up 3. What just happened? You moved it left 1 and up 3. Oh, so instead of doing all of this math, you could just go left 1 and up 3? Yes, you could. And sure enough, we take each point, move it left 1, up 3. Again, we're working on the F graph. Don't work on the red graph, work on the F graph. Left 1, up 3. I lost count. 1, 2, 3. Left 1, 1, 2, 3. And now we have our dots. Don't lose track of your dots. Mine are in purple here. And again, we have a ray. Whoa, whoa! A line segment and a ray. Pew-wee. And that right there is going to be your H graph. I know, right? It's pretty exciting. At least I think it is. Let's do one more transformation, all right? I have another graph of the same F graph. I want to start fresh, okay? So these are the same points. These are still, let's see if I can do this. These are still the values at A, B, C, and D, same values. All right, that's the F graph. Now, on top of this graph, well, we could make up another letter. I'm just going to go back to G. I'm going to make a new G graph, G of X, and I'm going to define it as follows. This is going to be the -2 F of X graph. Now, you see that -2? Ask yourself a question. Self, are you in with the X? No. No, you're not. You're not in with the X. So here's what this means. The X coordinates of these points will not change. That -2 is not in there with them. Instead, this will be a multiply. You do what it says when you're not in with the X. You will multiply by the Y coordinates. What do you mean? I am going to take -2 and multiply by the Y coordinates. All right, so take a look at the A point. The X value will stay the same. The Y coordinate gets multiplied. 0 times negative 2 shockingly stays 0. So that dot at A doesn't change. And what about the B value, or the B point? Negative 5, 2. Don't change the x. But the y coordinate, 2, gets multiplied by negative 2, and it becomes negative 4. So instead of negative 5, 2, it's negative 5, 1, 2, 3, 4. Do you see that B value? It has flipped over the x-axis and been stretched by a factor of 2. And that's exactly what this is doing, reflecting and stretching. Keep going. The C value, 0, negative 2. The 0 stays the same. We take the negative 2 and we multiply it by negative 2. It becomes positive 4. 0, 1, 2, 3, 4. Hey, flipped, stretched. Yeah, I know, right? Perhaps you saw this coming. 2, 0. It's going to stay 2, 0 because the x doesn't change and 0 times anything is 0. Yeah. Okay, so now let's look at this. Between the A and the B dots, we make a ray, line segment, ray. Well, would you look at that? This negative 2, the negative reflected it over the x-axis. It's a vertical reflection. And the 2, whoop, stretched it. I know, it's kind of a little summary of what's going on. All right, ask yourself, are you in with the x? Fiddle with the x coordinates. Are you not in with the x, which is what we have here? Don't change the x coordinates, change the y coordinates. All right.